folks, Mr. G here with another educational video. This time we're going to be talking about dividing fractions. Before we get into dividing fractions, let's remind ourselves what dividing really means when we're talking about whole numbers. When we're doing division, what we're really looking to do is take this 12 and split it into 3 equal groups. And then we want to know how big is each group. If we have 12 objects, we need to find a way of splitting into 3 equal groups. And as it turns out, if we make our groups size 4, we can split it into 3 groups of 4, so 12 divided by 3 equals 4. That's the size of our groups. But what does it mean if we take a fraction and divide it by a number like 3? Well, it's the same idea. We're trying to take this 1/4 and split it into 3 equal groups. And we can do that using a picture. So if this is our picture for 1/4, we've got 4 pieces and we've colored in one of them. What we want to do is split up this piece into 3 equal groups. And then we can ask, how big are each of these pieces, right? We want to know how big each of this group is. And that would be our answer. Now with a fraction diagram, the only way that it works is if all of our pieces are the same size. These pieces inside here aren't the same size as these pieces out here, but if we divide all of our pieces into groups of 3, then all of the pieces would be the same size. So now that we've divided all of our pieces into groups of 3, all of our pieces are the same size, and we can see that we're interested in one of these pieces, and there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So we have 1 over 12, and that would be our answer. What about another example like 3 over 4 divided by 2? This would be our fraction diagram. Since we're dividing it by 2, we need to take all of these pieces that we have and divide them into 2. Now, if we wanted to figure out this whole area divided by 2, if we divide this in half, we want one of these. If we divided this in half, we want one of these. And we divide this in half, we want one of these as well. That would give us half of this total shaded area. All 3 of these added together. But just like our last example, if we want to use our fraction diagram, we also have to divide up this empty space. That way, all of our pieces are the same size. Now what we can see is we've got 3 pieces that we're interested in out of a total of 1, 2, 3, 4, 5, 6, 7, 8. So our answer would be 3 out of 8. If we were to take this area, divide it by 2, we'd take 3 of these pieces out of a total of now 8 pieces. Let's see if we can figure out a pattern here. 1 over 4 divided by 3 gave us 1 over 12. 3 over 4 divided by 2 gave us 3 over 8. What you might notice is that it looks like our answer comes from taking this whole number and multiplying it by our denominator here. And that is in fact the pattern that we're looking at. Another way that we can write this is that we can think about multiplying by 1 over this number here. Because when we take 2 fractions and multiply together, we multiply the tops and the bottoms together. This would be 1 times 1 to give us 1, 4 times 3 to give us 12, 3 times 1 gives us 3, 4 times 2 gives us 8. And this idea of division being multiplication, but with 1 over the number, also works if both of the things are whole numbers. If we go back to our first example of 12 divided by 3, this is the same as 12 times 1 over 3. And then we can remember that a whole number like this can be written as a fraction if we just give it a denominator of 1. Now we can multiply the tops together to get 12, the bottoms together to get 3, and we can reduce our fraction to get 4. The key idea here is that division is the same as multiplication by the reciprocal of whatever you're dividing by. So in this case, the second number. And reciprocal just means that we flip the fraction. Now for our first examples here, the second number hasn't been a fraction. But again, we can write whole numbers as fractions if we divide by 1. So if we have 3 over 1 flipped is 1 over 3. 2 over 1 flipped is 1 over 2. 3 over 1 flipped is 1 over 3. And as it turns out, this also works if both numbers are fractions. Division and multiplication by reciprocal are the same thing even for fractions. So if we take this example here, we can turn this into a multiplication problem by flipping our second fraction. And we covered how to do problems like this We multiply the tops together, we multiply the bottoms together, and then we just need to reduce this fraction to finish off our question. If you want to see how to do this type of question using a diagram, there are some examples in the textbook that you can look at. So if you're interested in how we could represent this using a picture, I encourage you to look at the textbook here, but I'm not going to go over the examples in this video. This also works if we're dividing by an improper fraction. Again, we just flip it. We multiply the top and bottom together, we reduce our fraction, and we can get our final answer. Now if we divide by a mixed fraction here, you might be tempted just to flip the fraction and change it to a multiplication question like this. This is not correct. The first thing we need to do is take this and turn it into an improper fraction before we flip. If you remember, we had a little shortcut where we multiply these two numbers together and add it to the top. So this would be our question now that we've converted our mixed to an improper fraction. Once we're here, we can solve it just like we did up here, flip the second one, multiply the top and bottom together, and then after reducing our fraction, we can get our final answer. All right, let's check your understanding. 3 questions here. Pause the video, try them out for yourself, and then we'll go over the answers in just a second. All done? All right, let's go over the answers. For our first one, we need to start off by drawing 3/5. Now, drawing fifths in a wheel is kind of hard, but you want to draw this kind of like a star shape. We're dividing it by 2, so we're going to take all of these areas here, and we're going to divide them in half. If we want half of this total, that means we need to take one chunk from here, one chunk from here, and one chunk from here. But keep in mind, if we want to use this as a fraction diagram, we also need to cut these 2 chunks in half as well. That way all of our pieces are the same size. And now we can see we've got 3 highlighted pieces, and we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, so our answer would be 3 out of 10. For our second one here, we're dividing 2 fractions. We flip the second one because division is the same as multiplication by a reciprocal. Once we're here, we could multiply the top and the bottom, but we also have an option of doing what's called cross-reducing. So if we have a factor that's shared by these 2 numbers, we can reduce it. So we can divide this by 5 and divide this by 5. Basically, it's like reducing a fraction where we divide the top and the bottom, but we're focusing on these cross terms here. And we can do the same thing with the other cross, divide this by 2 and divide this by 2. Once we get it to here, now we can multiply the 2 tops, which would give us 9, and the 2 bottoms, which would give us 20. We could have done multiplication on the top and the bottom and then reduced it afterwards. You would have gotten the same answer if you did that, but the numbers are a little bit bigger. For our last question here, we have to convert both of these into improper fractions first before any flipping can be done. We multiply the number up front and the denominator, add it to the numerator. Now that we're here, we can flip our fractions. Again, we can do some cross-reducing if we'd like. We can divide that by 2, divide that by 2. We can't do any reducing with 3 and 19. So when we multiply this out, the top will be 12, the bottom will be 19. That's the end of the video here. Stay tuned for part 2 where we're going to be going over some fraction word problems that involve multiplying and dividing. See you then.